Hey class, this is Mr. Win here with a video on 17.3 called Applying the Zero Product Property to Solve Equations. So, there's this thing called the Zero Product Property. What it says is if the product of two quantities equals 0, at least one of the quantities equals 0. Okay. So for example here, if I know 9 times some number equals 0, I know this number has to be 0 because 0 times anything is 0, right? 9 times 0 is 0. I couldn't have any other number here to make this 0. Okay, this would be incorrect. So this has to be 0 in order to do 9 times 0 is 0. Basically, 0 times anything is 0, and the converse is kind of holds there. Okay, 0 times 4 gives us 0, right? So in algebraic notation, if AB equals 0, so if A times B, two numbers times each other equals 0, then either the first number A, whoops, that's not an A, the first number A has to equal 0, or the B has to equal 0, right, in order for the product to be 0. Okay, so in order to have something times something equals 0, at least one of them has to be 0. Let's look at this, part A. Consider this equation. X minus 3 times x plus 8 equals 0. Let A equals x minus 3 and B equals x plus 8. Now we have two things multiplying by each other. I got my A value over here, and I got my B value right here. I'm doing A times B. So we can use the zero product property. Here, if we know that A times B equals 0, so A times B equals 0, that means, using the zero product property, either A equals 0 or B equals 0. Okay, we said that A is equal to x minus 3, is that factor, and we said that B is x plus 8. Okay, what that means is either x minus 3 equals 0, this was our A, or x plus 8 equals 0. If x minus 3 equals 0, I can actually solve for x by adding 3 on both sides. X has to be 3. Or the other case, x plus 8 equals 0, I could solve, sorry, I never write 8, it's like that, I don't know why I started. Okay, I could subtract 8 on both sides, and then x is equal to negative 8. So the solutions for this equation, there's two solutions. It's either x, or actually it would both be x equals 3 and x equals negative 8. Recall that the solutions of an equation are the zeros of the related function. So the solutions of the equation are the zeros of the function. The function is that factored form of the quadratic x minus 3 times x plus 8. Because they satisfy f of x equals 0. I think this was in 17.1. You can go back and check what we did there. The solutions of the related function. Okay, well, it's just going to make me write it again, but that's fine. X minus 3, x plus 8. The solutions are, we said it was 3 and negative 8. Really, I should say that where the x value is 3 and where the x value is negative 8. Okay, so let's apply this property a few more times. So we have this function a, we have x minus 15 and x plus 7. If we're looking for the zeros of this function, that means I want to find out what x values I need to make this function, to make this equation true, equals to 0. So we set it equal to 0. I actually did it, they did it over here. They use the zero product property to show that either this term has to be 0 or this factor has to be 0. So they considered both possibilities. Number 1, x minus 15 equals 0. When they tried that, they added 15 on both sides. And they found that, well, if that's the case, then x equals 15. Alright, the second scenario, let's see what happens when x plus 7 equals 0. When we try that, subtract 7 on both sides, we found that x is equal to negative 7. So this is not a contradiction. We have x equals 15, and we have x equals negative 7. That means one of those, either one of those can be true. Okay. So either of those can be the case. That means for our function, our zeros are going to be 15 and negative 7. Those are going to be our solutions. Let's do example B. F of x equals x plus 1 times x plus 23. Okay, we're solving for the zeros, so I set this equal to 0. Two scenarios. Scenario 1, my first factor equals 0. Again, remember, if this was 0, 0 times x plus 23 is going to equal 0 because 0 times anything is 0. That's the zero product property. So x plus 1 is equal to 0. This is our first case. If that's true, yeah, I'm not sure why it makes us write it here twice, but it's fine. So we're going to subtract 1 on both sides, so x is equal to negative 1 in this case. Now, case number 2, x plus 23 is 0. I'm going to subtract 23 on both sides, so x equals negative 23. That means the zeros of my function is x equals negative 1 and x equals negative 23. Or really, I should say negative 1 and negative 23. Okay, it's really, really important. Usually I don't emphasize this a lot, but really important to do these practice problems 6 and 7. Alright. So, assuming you did that, we can move on to the next part. The distributive property states that for real numbers, this property holds. Okay, so it's basically just saying if A is outside, it's going to distribute to both things. Also, the reverse process works. We can factor out this A on the outside. That's the reverse of distributing. It applies to polynomials as well. So, for example, if I have the same factor x minus 4, I can factor that out. What I'm left with is 3x and 5. That leaves me 3x plus 5. We can use this property along with the ZPP, which stands for zero product property, to solve certain equations. Okay. Here, let's just look at one example. X minus 4, that's a common factor. I can take out that common factor. Inside, I'm going to be left with 3x and 5. Okay, 3x and 5, so 3x plus 5 is that factor. X minus 4 is here and here. Okay, if you get confused with that, just, give it a try and then work backwards to see if you did it right. So I can take this x minus 4, distribute it to my 3x. That's 3x times x minus 4. And then I can take it and distribute it to my 5. That's 5 times x minus 4. Okay, it's just the reverse process. Try to wrap your head around that. We talked a little bit about it with factoring by grouping, but we only touched on that like once. So, assuming you know how to do that, now we have a quadratic in factored form. Two linear factors, we've got 3x plus 5, and we've got x minus 4. Case number 1, I check what happens when 3x plus 5 is equal to 0. And I can solve for x, so subtract 5 on both sides, divide both sides by 3, they got negative 5 over 3. Case number 2, I see what happens when x minus 4 equals 0. I'm going to add 4 on both sides. In this case, x is equal to 4. That means the solutions, or the zeros, are going to be negative 5 over 3 and 4. So let's do this one more example, part B. Again, let's see what we can factor out. Do we have any common factors for here and here? Well, it's already got the x plus 2 grouped up nicely for us. They both have an x plus 2, so I'm going to take out this factor x plus 2. Inside my parentheses, I'm going to be left with a negative 9 plus a 3x. So negative 9 plus 3x. And again, you can distribute this polynomial back to each of those terms to show that this is indeed true. Okay, here is our factored form. Negative 9 plus 3x times x plus 2 equals 0. We're looking for the zeros, so we say equals to 0. Again, two cases. Case number 1. My first linear factor, negative 9 plus 3x equals 0. Okay, same thing. We're going to solve for x. Add 9 on both sides. Divide both sides by 3. I got x equals 3. Case number 2. What happens when x plus 2 is equal to 0? Well, I'm going to subtract 2 on both sides. So x is equal to negative 2. Here's my two solutions. I got 3 and negative 2. So my solutions are x equals 3 and x equals negative 2. Alright, again, I usually don't emphasize it this much, but make sure you actually do these problems number 9 and number 10, because you're really going to need to know how to find those zeros or those solutions using a method like this. Alright, this explain 3 portion, it should be mostly the same thing except putting it inside a real world problem. So let's look at just, why don't we look at this just real quick. The height of one diver above the water during a dive can be modeled using this equation. H is height and t is time. Find the time it takes for the diver to reach the water. So the height is the height above the water. Okay, so here's this guy, jumping off a cliff. So his height, so if our height is how far above the water, when he hits the water, his height is 0. When he starts at the top, well, I don't know how high up that is, but it's some height. Okay. Identify the important information. The diver reaches the water when h is 0. To find the time it takes for the diver to reach the water, we want to set the equation equal to 0 and use the zero product property to solve for t. And then from there, you solve. So here's the equation. We set it equal to 0. Here I got two linear factors, 4t plus 5 and t minus 3. Don't worry about this negative 4, just the linear factors. Case number 1, 4t plus 5 is 0. Case number 2, t minus 3 is 0. So we solve each of those. 4t plus 5 is 0. Subtract 5 on both sides. T equals negative 5 over 4. Case number 2, t minus 3 equals 0, so t equals 3. That means our zeros are negative 5 over 4 and 3. Now, what's unique about real-world problems is that you have to actually think about the answers to see if it makes sense. So here, t is representing time. Since time cannot be negative, the time it takes for the diver to reach the water is just our positive answer. So in 3 seconds, the diver is going to hit the water. And then we can check to see if our answer is reasonable by plugging back into our equation to find our height. So if we plug in 3, right there and right there, I get 8, I get 0. This is our height. Our height is supposed to be 0 after 3 seconds. Okay, the diver will reach the water after 3 seconds. Alright, that's it for this video. Have a good one, and think win-win.